So question 4 says, find the solution of the system of equations by substitution. So again, there's many ways to solve a system of equations. The more math you take, you'll discover there's some very powerful strategies that really start to lean into a lot more of what we would call programming, and you start to understand more of the foundations of programming. Right now, we're still just kind of picking up on some of the more basics of programming. Substitution is a very powerful strategy in programming. So again, in a two-variable equation like this, like these represent lines. A line itself has infinitely many solutions on it. But now, when working with a system, and like I said, we're going to work with two unknowns, so we have to have so as I was saying, when working with a system of equations with two unknowns, we need to have a set of two equations. And when it comes to solutions, these are the different scenarios. There can be one solution, which will be the point of intersection or an ordered pair. There can be no solution, which means the two lines basically were parallel. There can be infinitely many solutions, which means the two lines were what we call coincident. They lie on top of each other. In this case, the solution would be represented by the equation of a line. So in the substitution method, what we want to do is rearrange either equation to isolate one of the variables. So we don't want standard form this time. We want to isolate one of the variables. So if I look at these two equations, notice that the second equation, the variable is already isolated. So step one is done for us. So what we want to do next is substitute the equivalent expression from step one into the other equation. So what they're saying is, since A equals 5 plus B, what we want to do is replace the 5 plus B in for A in the other equation. So this turns into 3 times 5 plus B plus 3B equals 75. So we have that going on for us. Let's see here. This thing to put done all that. All right, so we have that going on. So again, since A equals 5 plus B, I can replace A in the other equation with that expression 5 plus B, since they're equal. So I'm allowed to replace them since they're equal. What this does, this creates an equation with one variable. So now what we want to do is solve this equation for that variable. So we can remove the parentheses using the distributive property. We can combine like terms. So this 15 can come to the other side by subtraction. So 75 minus 15 would be 60. And I can divide both sides by 6. So 60 divided by 6 would be 10. So I found that variable to be 10. Now what I can do is I can now substitute this 10 back in over here to find A. So remember how this variable is already solved, isolated. I can now come back over here and find A rather easily by substituting the value of B back over here. So on the substitution method, there's harder work on the front end, but the back end is rather easy to do most of the time. So to find A, since A equals 5 plus B, we can replace the B with the 10, and 5 plus 10 gives me then this 15. So A does equal this 15. So our solution would be A equals 15 and B does equal 10. As an ordered pair, we would write that as 15, 10 as an ordered pair. And as we said before, that would be considered consistent and independent. Now you could also check your solution by substituting these values back in, and it's supposed to make both of these equations true. So if you want to verify that, you can actually double check yourself to see if that really is right. So if I have 3 times 15 plus 7 times 10, does that equal 75? Well, 3 times 15, oops, that should be 3 times 10 there, I'm sorry. So 3 times 15 and 3 times 10. So 3 times 15 is 45 and 3 times 10 is 30. Does 45 plus 30 equal 75? Well, yeah. The other equation, A was 15. Does that equal 5 plus, and B was 10? Does 15 equal 5 plus 10? Yeah, that does check out. So it does satisfy both equations. So that's the only ordered pair that satisfies both these equations at the same time.